This is the return demo of nav 213 E-Plan 1D chart number 1. So the scenario description is at 10:30 hour, the ship is on course 2 to 5 degrees true times 8 knots with the use of visual method. The OOW observed Aggie Point Lighthouse, which bears 0 to 5 degrees with a distance of 10 nautical miles. After an hour, the same object was abeam to starboard. First, I will convert the relative bearing to true bearing by adding 0 to 5 degrees relative to 2 to 5 degrees true bearing. To achieve the true bearing, so I calculated since 200, so I will calculate 2 to 5 degrees true bearing. At the same time, 0 to 5 relative. So 0 to 5 degrees. The answer is 250 degrees. Okay. Since I already figured out 250 degrees, I will find this to the compass rose. 250 degrees. Hold on. Okay. And then I plot my true bearing to Aggie Point Lighthouse. I align my triangle to the meridian line into Aggie Point. Slide it up. And then put a mark here. I align my triangle to the meridian line. I'm using this to get any easy, fast and reliable. This is very easy when you use triangle. Okay. So this is my focal point to 250 degrees. Okay. And then I move it Aggie Point. So this is now my true bearing, which is at 10:30 hour. The relative bearing 250 degrees true, and the distance of it is 10 nautical mile. So here's the thing. I'm gonna measure this to my compass divider. So this is my compass divider. This is very useful. So I got the 10 nautical miles. I put a semicircle here. Okay. Just a second. So I'll be getting the 10 nautical miles. Put semicircle, as I've said, and then I can now put my course, which is 225 degrees. So I'll find it on the I'll find it on the compass rose, 2 to 5 degrees. Okay, but first thing first, I need to measure it here. If it's accurate. Okay, it's accurate. So 2 to 5 degrees. I here. And I slide it out. I slide it up into this. Okay, since I put 225 degrees here, and then I slide it up until I reach a point. This is the exact 225 degrees. Okay, and on the performance criteria, first plot the first LOP acupoint. It is now done. It is now done when I double inspection it. First plan of position, then apply distance the alter an hour after an hour from the first observation. So the distance is 8 nautical mile. Okay, so after an hour, when we convert 8 nautical mile, when we convert to the 8 nautical miles, since 1 nautical mile is equivalent to 1 knot, so it will turn into 8 nautical mile. So we plot that. So this is the dead reckoning. But hold on. Okay. First thing first, I put it down 250 degrees and 225 degrees here. Okay. All right. So since I already figured out 8 nautical mile, I use this to measure. Okay, hold on. So this is 8 nautical mile. Okay, hold on. Okay, so this is the sign of point of, I mean, what do you call that?
Mapay pagkukuan nimo.
Okay,
Mura
so
kag naka
okay, since I already got the 8 nautical mile distance, what happened is this is the dead reckoning. Okay, this is the dead reckoning of 11 1100 1100. Okay, and when I'm going to use the international way, what we're going to do now here is I'm going to put a second line. Okay, so since I figured it out, so this bearing is 315 degrees. Okay, 315 degrees. Okay, Okay. This is the 315 degrees. So the dead reckoning here is 1130. Okay, just a second. Okay, this is 315 degrees and 1130 hours. So the last step is I will transfer this to the running position. This one. Okay. Mhm. I align this to this one. Okay, I'm done.